very much. Delighted to be here this evening during our global moisture. And I hope that everyone managed to find a parking place relatively close to the building here. I'm going to try to go through this pretty rapidly. I'm delighted at the interest that some people have. Strong advocate of a marketplace of ideas, and I appreciate the opportunity of confronting people who might disagree and perhaps having an interchange after the talk. In the summer of 1988, the East Coast was in the grip of one of the worst heat waves in history, and farmers in the Midwest were experiencing the worst drought since the Dust Bowl days of the 1930s. Crops browned and shriveled, reservoirs were nearly depleted. The Mississippi River sank to its lowest level since 1872. On June 23rd, Washington, D.C. was sweltering in 100-degree heat, and at a Senate committee hearing on the greenhouse effect and global climate change, Dr. James Hansen, a very respected atmospheric scientist and director of NASA's Goddard Institute for Space Studies, was giving alarming testimony. Quote, "The Earth," he said, "is warmer in 1988 than at any time in the history of instrumental measurements. The rate of warming in the past 25 years is the highest on record. The 4 warmest years have all been in the 1980s," close quote. Hansen then declared with 99% confidence that this represented a real warming trend, his words, which he could attribute to the greenhouse effect. He concluded, quote, "In my opinion, the greenhouse effect has been detected, and it is changing our climate now." Hansen's statements were widely reported and touched off a firestorm of controversy that's raged to this day. What could happen if the Earth heats up, people wonder? The answers given in the popular media have been scary. Time magazine speculated that the Great Plains could be depopulated as people migrated to Canada to escape droughts and heat. In popular science, John Milliman of Woods Hole Oceanographic Institution warned, quote, "Don't buy land in New Orleans. Melting polar ice," he said, "could raise sea levels and inundate coastal cities." "New York City might drown," wrote environmentalist author Jonathan Schell in Discover, summarizing the views of some scientists. "Or if it managed to hold back the waters, it might become as hot as the Sahara." On NBC's Today Show, biologist Paul Ehrlich declared, quote, "We could expect to lose all of Florida, Washington, D.C., and the Los Angeles basin." In a paper delivered at a Washington forum, Ehrlich added that chronic droughts caused by global warming could cause food stocks to dwindle, resulting in 50 million to 400 million deaths by starvation. In his book, Global Warming, Dr. Stephen Schneider of the National Center for Atmospheric Research, or NCAR, spun out the following as a plausible scenario of a greenhouse future. A baseball doubleheader in Wrigley Field, Chicago, canceled due to a thick black haze caused by a huge forest fire in Canada, caused by a major drought, caused in turn by the greenhouse effect. He also conjured the image of a killer heat wave in New York, followed by a hurricane that devastates Long Island, again generated by the greenhouse effect. As if such scenarios, endlessly repeated and ever amplified by the media, weren't frightening enough, the public had further reason to take them seriously because of the response of government officials here and abroad. The National Academy of Sciences had put its prestigious stamp of approval on forecasts like Hansen's. The U.S. State Department established an Office of Global Climate Change, and internationally, an intergovernmental panel on climate change was set up to coordinate policies between governments. In Paris last July, the leaders of 7 major industrial nations, including President Bush and British Prime Minister Margaret Thatcher, issued a joint statement calling for common efforts to limit emissions of carbon dioxide and other so-called greenhouse gases that are believed to be trapping too much solar heat in the atmosphere. In the Netherlands last November, a conference of 68 nations endorsed that goal. To stem such emissions, many environmentalists, including those at our own Environmental Protection Agency, or EPA, have proposed huge new tax increases and draconian regulations. But these tax and regulatory measures have a heavy price tag. Even EPA Director William Riley, a true green environmentalist who accepts the frightening global warming forecast and is sympathetic to such proposals, concedes their tremendous costliness. He said in a speech last June that, quote, "To slow down the global heating process, the scale of economic and societal intervention will be enormous. It will involve far greater inconvenience, dislocation, and cost," close quote. Clearly then, the stakes are high. On the one hand, the public is confronted with dire forecasts of environmental catastrophe, what Hansen has described as a time bomb. On the other, it's confronted with alleged cures whose predicted costs are acknowledged, even by their advocates, to be enormous. But do we really have to make that choice? Obviously, that depends on the validity of the threat. The global warming issue has been studied by scores of scientists around the world. Many believe the danger is real, while many others are far less certain. So how is it possible for those of us who aren't scientists or atmospheric physicists to weigh these competing claims and decide who's right? Like most journalists, I'm a generalist, not a specialist. That's not necessarily a disadvantage, by the way. The issue here isn't one of expertise, but of evidence. The technical claims of experts and specialists must be assessed for credibility in the same way that judges and juries must assess technical information in a courtroom. Claims must be held up to the universal rules of evidence and logical proof, and not simply taken at face value, no matter how impressive the credentials of the expert. What then is the evidence for global warming? How real is the threat? That's what I tried to find out over a period of several months when I was assigned to do an article on the subject for Reader's Digest. I interviewed Dr. James Hansen and other major scientific backers of the global warming theory. I read their papers and books. I contacted internationally recognized specialists in such fields as deforestation, agriculture, volcanic activity, acid rain, and ozone depletion. I talked to policy analysts at the EPA and interviewed EPA Director William Riley. I also interviewed and studied the works of scientists skeptical of the global warming theory. The Reader's Digest Research Department independently checked each fact reported in the article with additional independent authorities. The article, which emerged from this mass of material, appeared in the February 1990 Reader's Digest and was titled, "What is the Truth About Global Warming?" My intention here is to present the substance of that article in greater detail and to address issues that couldn't be tackled in a brief magazine piece. The first thing that should be clarified is terminology. The so-called greenhouse effect is not exactly the same thing as global warming. The greenhouse effect describes the basic atmospheric phenomena that makes life on Earth possible. When sunlight warms the Earth, part of it is reflected back into space as infrared heat. But certain gases in the lower atmosphere block and trap some of this rising heat, something like the glass panes in a greenhouse. This trapped heat warms our planet to an average temperature of about 59 degrees Fahrenheit. The heat-trapping gases, or so-called greenhouse gases, include water vapor and also trace amounts of carbon dioxide, methane, nitrous oxide, man-made chlorofluorocarbons, and other gases. If greenhouse gases were more abundant, they might trap too much heat. Venus, for example, has about 60,000 times more carbon dioxide in its atmosphere than does the Earth, and its average temperature is above 800 degrees Fahrenheit. But if these gases were too thin or entirely absent, there would be nothing to block the reflection of solar heat back into space, and average temperatures on Earth would plunge below freezing, as they are on Mars. The greenhouse phenomenon was described as early as 1863 by British physicist John Tyndall. Quote, "Remove for a single summer night the aqueous vapor from the air which overspreads this country, and the warmth of our fields and gardens would pour itself unrequited into space, and the sun would rise upon an island held fast in the iron grip of frost, close quote. 3 decades later, Nobel Prize-winning Swedish chemist Svante Arrhenius calculated the heat absorption properties of carbon dioxide and water vapor in the air. And he concluded that the Earth would warm several degrees Celsius if the amount of carbon dioxide doubled. The existence of a greenhouse effect, then, is a matter of long-established science and is non-controversial. Whether the greenhouse effect is causing global warming, however, is very controversial. Most people are understandably confused about a variety of atmospheric worries: the greenhouse effect, the ozone hole, acid rain. These terms become a kind of a mental jumble, and before proceeding, I think it's advisable that we try to sort them out. For all practical purposes, the ozone hole issue has nothing to do with the greenhouse effect. Ozone is a naturally produced form of oxygen. In the lower atmosphere, it's a pollutant, a component of urban smog. However, its presence in the upper atmosphere is beneficial. It helps shield us from excessive ultraviolet sunlight, which can lead to certain skin cancers. But in 1985, scientists confirmed a temporary thinning in the ozone layer over Antarctica. This thinning was soon dubbed, somewhat misleadingly, the ozone hole. And its presence led to a new worry. If this ozone hole grew to encompass populated areas, it could cause increased penetration of ultraviolet sunlight, and perhaps an epidemic of new skin cancers. There remains much mystery about the so-called ozone hole, but what's known so far makes such panicky predictions unjustified. The most popular theory for ozone thinning is that man-made CFCs escape from spray cans, refrigerators, and air conditioners. They eventually rise into the upper atmosphere where they break down under ultraviolet sunlight and release chlorine atoms. These atoms in turn combine with and destroy ozone molecules. But blaming ozone destruction solely on man-made chemicals may be premature. Nature also destroys ozone. Volcanoes, for example, can release chlorine into the upper atmosphere in amounts that dwarf any produced by man. The 1976 Augustine volcano in Alaska is thought to have sent aloft chlorine compounds in amounts 570 times the entire previous year's world production of chlorine and CFCs. Due to special atmospheric conditions, the ozone hole appears only from September to November in the swirling vortex of polar winds that keep it centered over Antarctica. In the absence of these unique conditions, ozone depletion can't occur. That's why the hole repairs itself when the conditions change a few weeks later. And for the same reason, the ozone hole fluctuates. In 1988, when conditions weren't right, there was far less ozone thinning. But the hole can't expand to become a global menace. No increase in surface ultraviolet radiation has been detected outside of Antarctica, nor has there been any detectable impact on life forms there. John E. Frederick, professor of atmospheric science at the University of Chicago, chaired a United Nations panel that evaluated the ozone hole. He dismisses fears of a skin cancer epidemic as, in his words, science fiction. Quote, "You would experience a much greater increase in biologically damaging ultraviolet radiation if you move from New York City to Atlanta than you would with the ozone depletion that we estimate will occur over the next 30 years. Now, what about acid rain? This term describes the increased acidity of rain and snow, widely believed to be caused by emissions of sulfur dioxide and nitrous oxide from automobiles and coal-burning power plants. It's thought to damage trees and plants and acidify lakes, perhaps threatening fish. However, volcanic eruptions produce sulfur dioxide too. It becomes droplets of sulfuric acid in the stratosphere, forming a global haze. For instance, the 1982 El Chichon eruption in Mexico blanketed the planet with a sulfuric acid cloud, leaving acid residue on the Greenland ice sheet. Ironically, this acid rain haze works to offset global warming. Albert Arking, who heads the Goddard Space Flight Center's Climate and Radiation Branch, explains that it, quote, partly screens the Earth from the sun's rays and cools the Earth, close quote. Since neither the ozone hole nor acid rain contribute directly to the greenhouse phenomenon, let's get back to that. Because concentrations of greenhouse gases have been steadily rising over the last century, some scientists are worried that this may be leading to global warming, that is, an artificial heating up of the planet. Researchers at the Goddard Institute for Space Studies, that's Dr. Hansen's group, and at the University of East Anglia in England, believe that temperature records show the globe has already warmed about 1 degree Fahrenheit over the past century. These scientists and others, such as Stephen Schneider of the NCAR group and Syukuro Manabe of the Geophysical Fluid Dynamics Laboratory, foresee a doubling of greenhouse gas concentrations in our atmosphere during the next half-century or so. Using complex mathematical computer models of global climate, they predict that this buildup will raise global temperatures from 3 to 9 degrees Fahrenheit. It is this possible global warming or enhanced greenhouse effect that worries many people. For even a small rise in average global temperatures could lead to dramatic changes in the Earth's climate. Droughts, killer heat waves, monster hurricanes, and flooded coastlines due to melting polar ice caps are just a few of the possibilities that concern them. Now, why have the greenhouse gases been building up? Nature accounts for most of the greenhouse gases in the atmosphere. Now, this is obvious in the case of water vapor, the most plentiful of the greenhouse gases. But much of the buildup of greenhouse gases over the past century is man-made. Carbon dioxide, the most abundant trace gas, is released by volcanoes, oceans, decaying plants, and by the breathing of animals and humans. It's also removed naturally from the atmosphere by dissolving into the ocean surface, where it's eventually absorbed into shells and becomes part of the limestone deposits on the sea floor. Plants also draw a great deal of carbon dioxide from the air and into their leaves, convert it to carbon, and store it as plant tissue. Altogether, these processes make up what is called the global carbon cycle. But besides its natural sources, carbon dioxide is also released when we burn fossil fuels such as coal, oil, and wood. Carbon dioxide is a virtual inescapable byproduct of industrial civilization. In fact, the amount in the atmosphere has grown by an estimated 25% or more since the Industrial Revolution began about 200 years ago. Over 11% since 1958 alone, when continuous measurements were started at the Mauna Loa Observatory in Hawaii. With population increase and economic development, land previously covered by trees has been cleared for farming in cities, and the demand for tree products has expanded enormously. In places like Brazil, thousands of square miles of tropical rainforest are being cleared and burned. This deforestation, many believe, fosters global warming. When trees and plants grow, they remove carbon dioxide from the air, and when they're cut down, they cease to do so. And when trees are burned, they release stored carbon dioxide back into the atmosphere. However, millions of acres are also planted with seedling trees each year, even in tropical areas such as Southeast Asia. And new studies reveal that the impact of forest destruction on global warming may be far less important than initially calculated. Researchers Daniel Botkin and Lloyd Simpson at the University of California and Sandra Brown at the University of Illinois recently discovered that the carbon content of the world's forest has been vastly overestimated. This suggests that deforestation may not be as great a source of carbon dioxide emissions as once thought. And by implication, also that any international tree planting campaign would have far less impact in mitigating global warming. Methane, the next most abundant greenhouse gas, is released when organic matter decomposes. Natural sources include swamps, the guts of cud-chewing animals, and even termites. But the amount of methane is increasing about 1% per year, largely due to natural gas use, mining, the cultivation of rice paddies, and increased cattle raising. Nitrous oxide has also been increasing in the atmosphere since pre-industrial times. It comes mostly from natural sources, but also from the use of coal, gasoline, ammonia, and fertilizers. Finally, chlorofluorocarbons, or CFCs, are synthetic, man-made chemicals used widely in refrigerators, air conditioners, plastic foams, solvents, and spray cans. The amount of CFCs escaping into the atmosphere is tiny in relation to carbon dioxide, but CFCs are thousands of times more potent in absorbing heat. They've also been implicated in the so-called ozone hole, which I already mentioned. To sum up, global warming proponents have two established facts on their side. First, the existing factors remain the same. Climatic factors interact in very complex and poorly understood ways, and some of these may significantly counteract any warming that might otherwise occur through a variety of feedback mechanisms. At any given time, for example, clouds cover 60% of the planet, as anyone stepping outside this evening can attest. Clouds trap rising heat, but they also reflect sunlight back into space. High, thin cirrus clouds tend to let in solar energy while trapping the rising heat, and thus warming the planet. However, thicker clouds, such as the stratocumulus layers, reflect more solar energy back into space, cooling the planet. Recent satellite data compiled by NASA show that clouds on balance tend to keep the planet some 20 degrees Fahrenheit cooler than it would be under clear skies. For many scientists, this raises an intriguing possibility. If global warming occurs, the oceans would heat up. This would produce more clouds through evaporation, and the increased cloud cover might act as a kind of natural thermostat, blocking and reflecting the incoming sunlight back into space and sending temperatures right back down again. The British Meteorological Office had long estimated that if carbon dioxide levels double, global temperatures would soar about 9 degrees Fahrenheit. But after factoring into their computer models more realistic cloud simulations, they had to cut their recent warming predictions in half to less than 5 degrees Fahrenheit. A more recent prediction from them was at 3.4 degrees Fahrenheit. And then there are the oceans, which cover almost 3/4 of the Earth's surface and have a major effect upon short-term weather and long-term climate. But the interaction of oceans with the atmosphere is so complex that scientists have only begun to understand the mechanisms. Ocean currents store and carry heat over great distances. Rising moist air over the oceans transports heat into the atmosphere, then cools, dries, and descends. As I mentioned, the oceans also store large quantities of carbon dioxide. Distinguished atmospheric scientists, such as Hugh Elsasser in the Lawrence Livermore National Laboratory and Richard Lindzen at MIT, point out that global warming proponents are only crudely representing these complex processes in their computer models. As a result, they believe that these models may be badly overestimating the warming to be expected from a doubling of carbon dioxide. Even some of the top climate modelers concede the woeful inadequacy both of their understanding and their tools. Quote, "We really don't understand how the ocean behaves," said Sakura Manabe of the Geophysical Fluid Dynamics Laboratory. Stephen Schneider agrees, quote, "You really don't know what it's going to do," close quote. The oceans also influence shorter-term weather phenomena such as droughts. While some scientists hinted that the scorching 1988 drought in the American Midwest was an emerging symptom of global warming, a team of scientists at NCAR linked the drought to temperature and current changes in the tropical Pacific, an event known as the El Niño cycle or El Niño Southern Oscillation cycle. Such events can play havoc with some of the most dire predictions of global warming advocates. Take the rising sea level predictions. In 1985, the National Academy of Sciences report concluded that global warming would cause about a 39-inch rise in sea levels during the next century, enough to allow storm surges to engulf low-lying areas. But the trouble is, nobody told the oceans that that was how they were supposed to behave. When ocean currents were included in a recent computer climate model at the Geophysical Fluid Dynamics Laboratory, the resulting projection was that the Antarctic Ocean would actually cool, not warm. If true, this would diminish the likelihood that polar ice would melt, raising sea levels and causing coastal flooding. This study was confirmed by 9 other studies presented at the American Geophysical Society's fall 1989 meeting. The consensus was that the Antarctic and even Greenland ice caps will grow, not melt, in the event of any global warming. Why? Because a warmer atmosphere will carry more moisture, meaning increased snowfall at the North and South poles. As a result, the scientists cut earlier predictions of sea level rise by 2/3 to only about a foot, while conceding that the sea level could even drop by a couple of inches during the next 50 years. So despite the predictions of professional doomsayers, I'm afraid that for the foreseeable future, there will be no surfing competitions on the White House lawn. Besides ocean cycles, there are other natural cycles. Everything from sunspot activity to volcanic eruptions to long-term changes in the Earth's rotation and orbit. These powerful forces can easily overwhelm and dwarf the impact of minute changes in trace amounts of greenhouse gases. So can what is simply called natural variability of the climate, that is, large and seemingly spontaneous climate changes with no obvious cause. As Tim Barnett of the Scripps Institution of Oceanography puts it, quote, "The variability of climate from decade to decade is monstrous," close quote. For instance, there's the remarkable coincidence between sunspot activity and global temperature for the past 100 years. This correlation is charted in a recent report by 3 scientists with impeccable credentials. Frederick Seitz, past president of the National Academy of Sciences, Robert Jastrow, who founded the Goddard Institute of Space Studies and was James Hansen's predecessor as its director, and William Nierenberg, Director Emeritus of the Scripps Institution of Oceanography. They report, quote, "When solar activity increased between the 1880s and the 1940s, global temperatures also increased. When solar activity declined between roughly 1940 and the 1960s, temperatures also declined. When solar activity and sunspot numbers reversed and started to move up again, temperatures did the same. In fact," they conclude, "it is possible that a combination of natural and solar variability is the cause of the entire temperature increase observed since 1880, with the greenhouse effect relegated to a negligible role," close quote. Taken together, these feedback mechanisms are all powerful factors which can counteract or mitigate a global warming trend. Nor is there any certainty that global warming, even if it occurs, will be all bad for us. Milder winters mean lower bills for heating and snow removal, extended periods of outdoor activity, longer growing seasons and less frost damage. Increased carbon dioxide would also benefit farmers. Sherwood Idso, a research physicist at the Department of Agriculture's Water Conservation Laboratory, points out that more carbon dioxide, quote, "will tend to stimulate photosynthesis and so increase the productivity of crops," close quote. Despite claims that climate changes would be catastrophic, a 1989 EPA analysis for Congress concluded that, quote, "we could adapt to changing climate relatively quickly. Basic requirements for food and water could be sustained, and developed areas could be protected against rising sea levels, all at manageable costs." On a personal note, early this week I flew out of Pittsburgh on an assignment to Berkeley, California. Driving to the Pittsburgh airport, I had to negotiate icy patches on the road and bone-chilling sleet. But in Berkeley, the college students were lounging on the lawns under brilliant sunny sky in shorts and sunglasses. When I arrived back in Pittsburgh, I had to hike across the airport's endless parking lot, shivering in 25-degree temperatures. Entering my frosted vehicle, I concluded that few people in Berkeley would care to trade places with me. I also suspect that there are a few people in this audience who would feel threatened, or that there are few people in this audience who would feel threatened if Malibu-type weather were to come to the shores of Lake Michigan. I say this not to mock the concerns of those who see real problems in rising global temperatures, but those concerns, after all, presuppose that global warming is occurring or will occur. And that gets us to the crux of the issue. Where is any evidence that global warming is actually occurring? When I interviewed Dr. Hansen at the Goddard Institute, I asked him what constituted the best arguments and empirical evidence for the reality of global warming. What made him 99% certain that the greenhouse gases were now warming our planet? First, he said, there's evidence of what occurs on other planets as a result of greater or lesser concentrations of greenhouse gases. Quote, Mars, Earth, and Venus provide a perfect set to check our understanding of greenhouse warming, he says. He says, the thin carbon dioxide atmosphere on Mars produces a warming of several degrees. On Earth, it's several tens of degrees. And on Venus, it's several hundred degrees, close quote. Second, he said, is the Earth's own climate record. Deep drilling into the 2-mile-thick Antarctic ice sheet has enabled scientists to sample air bubbles that were trapped there as the ice built up. Hansen points out that, quote, the smallest carbon dioxide amount occurred when the Earth was coldest. Likewise, the most carbon dioxide occurred when the Earth was warmest. He regards this correlation between past gas concentrations and temperatures as and this is his quote, the most important check, close quote, on the global warming theory. Third, he said, there is the actual temperature record of the past 130 years, when greenhouse gases have been rapidly increasing. Average global temperatures, he says, have risen about 1.2 degrees Fahrenheit over the past century, more than could have been expected due to natural variations of the climate. And, he wrote last year, quote, the 5 warmest years in the history of instrumental measurements are in the 1980s, close quote. Fourth, there is the mathematical confirmation from so-called general circulation models, or GCMs. These computerized climate models, like the one at his Goddard Institute, show that the climate should have warmed up an average of about 1 degree Fahrenheit during the past century. This, Hansen says, is exactly what the temperature records show, another confirmation of the global warming theory. Finally, there's just the inherent logic of the theory itself. Quote, the one thing that has the greatest impact on my thinking is the increase in atmospheric carbon dioxide over the past century. It's just inconceivable, he adds, that is not affecting our climate. It's just a logical, well-reasoned conclusion that the greenhouse is here now, close quote. Let's consider each of these arguments in turn. First, the planetary comparisons. Hansen is correct when he says that comparisons with Mars and Venus prove that greenhouse gases trap heat in direct proportion to their concentrations in the atmosphere. But this doesn't get us very far, since everyone already agrees that the greenhouse effect exists. It still leaves a nagging question. How do the examples of Mars and Venus tell us how much a given concentration of carbon dioxide may affect temperatures here on Earth? Carbon dioxide concentrations on Earth are only 1/3 of 1/10 of 1% of the atmosphere, a very small amount. Venus has 60,000 times that amount, and Mars' atmosphere, though almost entirely composed of carbon dioxide, is very thin. These two examples, then, are so extreme, so different, and so complicated by other factors that they just don't tell us very much about how temperatures on this world will react to increases in carbon dioxide. And that's the $64 question. Just how sensitive is the Earth's climate to a tiny increase in the amount of a trace gas? This is not yet a matter of settled science, and planetary comparisons don't seem to be the most fruitful route to getting firm and finely tuned answers. So, as an empirical prop for the theory of global warming on Earth, planetary comparisons are obviously inadequate. Hansen and the global warming theorists seem on firmer ground when they cite our own Earth's climate history, as frozen in Antarctic ice core samples. In ages past, there seems to have been a direct correlation between increases in greenhouse gases and higher temperatures. Similarly, there was a correlation between ice ages and lower carbon dioxide in the atmosphere. Hansen and other greenhouse theorists often cite this correlation as historic evidence that changes in greenhouse gases can force changes in temperature on Earth. But how can you show that the carbon dioxide changes actually cause the temperatures to change? At minimum, you'd have to first show that the carbon dioxide levels went up or down first, and then the temperature levels followed. In other words, the buildup of carbon dioxide would have had to precede the rising temperatures. And lowered levels of carbon dioxide would have had to precede falling temperatures. I asked Hansen about this. Which came first, the changes in the amount of atmospheric carbon dioxide or the changes in temperature? Much to my astonishment, Hansen admitted that the temperature changes came first. In other words, during the warm interglacial periods, global temperatures went up first, and then the level of carbon dioxide went up. The same thing happened during the ice ages. First, the temperatures went down, and then the levels of carbon dioxide went down. As Hansen conceded to me, and I quote, "In fact, the CO2 changes do seem to follow the temperature changes, not precede them," close quote. Now, think about that for a moment. These ice core records are supposed to be a major prop undergirding the global warming theory. To fill the bill, they would have to show a cause and effect relationship, evidence that in the ancient past, greenhouse gases have forced changes in Earth's temperatures. Hansen even said, you recall, that these records constituted his strongest evidence, the, quote, most important check, unquote, of the theory. But the sequence of events they reveal is exactly backwards. It does absolutely nothing to buttress the theory of global warming. This awkward little detail, however, has not dissuaded Hansen from continuing to cite the correlation of past temperatures and carbon dioxide levels as support for the theory of global warming. You don't have to be a scientist to find this line of reasoning just a wee bit disingenuous. Ice cores aside, the most persuasive possible evidence for global warming would be reliable temperature records indicating that the planet is indeed warming up. Here, global warming theorists claim that there is hard data on their side. Temperature records compiled by the Goddard Institute, by the Climatic Research Unit at the University of East Anglia, and by researchers at the University of Massachusetts all seem to show about 1 degree Fahrenheit of warming over the past century, a period which has also seen a noticeable increase in the concentration of greenhouse gases. Another widely reported statistic is that the 6 warmest years globally since instrumental records began about 100 years ago have all been in the 1980s. If true, these statistics should give critics and skeptics some pause. But how valid are they? First, it turns out that the temperature records are far from reliable. In the past, there were relatively few measurements in the vast oceans of the southern hemisphere, and only 4 island monitoring sites in the Atlantic. Patrick Michaels, the Virginia State climatologist, found that the thermometer on one of these Atlantic islands, St. Helena, which covered the broadest area of the South Atlantic, had been moved down a mountain slope during the 1970s, giving a false impression of sudden warming. As for shipboard temperature readings, originally seawater was drawn aboard in open canvas and wooden buckets for measurement, where it could be affected by the air and sun. Later, seawater was piped aboard, and sometimes artificially warmed by ship engines and pipes. Measurements on land posed other problems. Thermometers were sometimes moved to airports, and elsewhere, cities occasionally grew up around them. The reflected warmth from the concrete surfaces created a so-called heat island effect, inflating temperature measurements as time passed. Based on these shaky measurements, the original estimate by Hansen's Goddard Institute was that there had been about 1.7 degrees Fahrenheit of global warming this past century, while the East Anglia group originally showed about 1.3 degrees Fahrenheit of warming. However, when Tom Carl of the National Climate Data Center corrected for the various biases in the temperature records, both estimates of warming had to be revised downward to about 1 degree Fahrenheit. Even then, troubling questions remain, causing greenhouse theorists to scratch their heads in puzzlement. For one thing, even their own temperature records indicated fluctuations that just don't jibe with the greenhouse theory. Thomas Wigley of the University of East Anglia, a proponent of the global warming theory, admits, quote, "This is clearly inconsistent with a simple interpretation of the greenhouse effect," close quote. But the biggest problem for the global warmers is emerging data calling into question even the 1 degree Fahrenheit warming in their own records. In late 1988, a study by the National Oceanic and Atmospheric Administration reported absolutely no evidence of any warming trend over the continental U.S. during the past century. Then, George Mall, an oceanographer with the Commerce Department's Atlantic Oceanographic and Meteorological Laboratory, reported early this year that during the past 30 years, temperatures in the southeastern U.S. have actually fallen a full degree Fahrenheit. The greenhouse theorists, such as Hansen and Schneider, argued back that the U.S. represents only 2% of the Earth's surface, and hence is not an accurate reflection of increasing global temperatures. But then came a new shock to the greenhouse theorists. Massive global oceanic temperature records compiled by scientists from MIT and the British Meteorological Office. Thousands of marine temperature readings over the past century were carefully corrected for the various biases and problems already mentioned, including even El Nino events, solar cycles, and volcanic activity. The conclusion? There appears to have been little or no global warming over the past century. Quote, no appreciable difference, unquote, between temperatures in 1856 and 1986, a 130-year period. Now, what about the claim that, quote, the 6 warmest years globally since reliable instrumental records began have all been in the 1980s, close quote. This quote has an interesting genesis. It appears to have originated with Phil Jones of the East Anglia Climatic Research Unit and appeared in the February 11, 1989 issue of New Scientist. The all-time record years were listed in descending order of warmth as 1988, 1987, 1983, 1981, 1980, and 1986. This same claim appeared in the New York Times of February 4th, 1989. And Stephen Schneider reports in his book that Jones confirmed to him the accuracy of this information. My researcher at Reader's Digest contacted East Anglia and also got this claim confirmed. It seemed so solid that we ran with it in my February article. Then a funny thing happened. One of the Digest's foreign edition editors challenged the accuracy of the claim. So I checked out my sources, and at first it seemed to hold up. I found that the same claim had appeared in Popular Science last August, in an Associated Press dispatch last September 12th, and in a report by the World Watch Institute. Then I found a slight change. James Hansen made a claim in a letter to the Washington Post this past February 11th that the 5 warmest years in history were all in the 1980s. That number, 5, not 6, cropped up in Science News on April 30th in 1988, and in a report co-authored by a Hansen associate, Cynthia Rosenzweig, for the University of Massachusetts. Then I learned from the Washington Post last June 21st that not the 6, not the 5, but the 4 warmest years in recorded history were in the 1980s. A February 1989 draft report to Congress by the EPA echoed this same assertion, as did the U.S. Department of Energy in a May 1989 booklet. The more I read, the more the globe began to cool. Now, I belabor this catalog of claims only because every single one of them, each originating from top climate experts and government sources, is false. Yes, indeed, the 1980s were the warmest decade on record. And we must keep in mind that our modern record keeping is both short and sloppy. But even if we allow the point for the sake of argument, the 1980s did not have the 6 warmest years, the 5 warmest, or even the 4 warmest. It had the 3 warmest, 1988, 1987, and 1983. Then came 1944. Also in the top 10 were 1938, 1941, and 1958, as well as 1981 and 1980. Yes, the 1980s were very warm, but not as warm as the scientists pushing global warming scare stories would have you believe. Taking everything into account, the U.S. Department of Energy recently concluded that, quote, "It is difficult to gather consistent, reliable data to provide evidence of temperature change," close quote. Richard Lindzen of MIT's Department of Earth, Atmospheric and Planetary Sciences, and a member of the National Academy of Sciences, echoes that view. Quote, "The data as we have it does not support a warming," close quote. And that is the scientific consensus, incidentally, despite what you may have read or heard in the media. Quote, "To say that we've all seen the greenhouse signal is ridiculous," says Tim Barnett of the Scripps Institution of Oceanography. "Even most climate researchers who think that warming is occurring are unwilling to go as far as Hansen and ascribe it to the greenhouse effect. Last May, 61 atmospheric scientists participating in a greenhouse workshop in Amherst, Massachusetts, issued a statement that, quote, 'Such an attribution cannot be made now with any degree of confidence,' close quote." What evidence then do the greenhouse proponents have left? One of their main tools used to plot climate change are general circulation models, or GCMs. The GCMs are computer simulations that attempt to represent known oceanic, continental, and cloud processes with mathematical equations. Scientists program in variables such as doubling of greenhouse gas concentrations to see what might happen to global temperatures and other aspects of the climate. But a computer is no more reliable than its input. The enormous complexity of this task forces climate modelers like Hansen, Schneider, and Manabe to divide the globe into vast grid squares, each grossly summarized by just a few statistics. Poorly understood cloud, oceanic, and hydrologic processes are often only crudely represented, even by the best GCMs. For example, when clouds were factored into the equations of 14 GCMs recently, they offered a wide range of inconsistent predictions. Because of crude tools trying to accomplish complex tasks, GCM calculations don't even accurately predict the past. That is, they don't match known greenhouse gas concentrations in the past to actual temperatures. Stephen Schneider concedes that most GCMs predict at least twice as much warming as should have occurred this past century than the greenhouse theorists think has actually happened. He writes that, quote, "It is an even bet that the GCMs have overestimated future warming by a factor of 2, close quote. We've now examined 4 areas that were supposed to offer evidence for global warming: comparisons with other planets, ice core samples, temperature records, and computer models. And as you can see, there isn't much there. Given this, we must now consider whether global warming theorists have met their burden of proof. First, let me explain what this burden entails. All knowledge, to be regarded as knowledge, must be supported by evidence and reason. In any controversy, then, the burden of proof rests not with the skeptic, but with the person making a positive claim of fact. In the absence of convincing evidence and sound reasoning that something is the case, the claim is nothing more than an arbitrary assertion, and we're justified in dismissing the claim out of hand. For example, I can't say, little green men from Mars exist. Prove that they don't. That's not fair. You can't refute facts that haven't even been presented or established in the first place. The burden of proof rests on the person asserting such a thing. Now, suppose I say, well, look, I can't prove little green men exist, but you can't disprove it either. Since this is an issue with far-reaching implications, let's err on the side of caution and act as if my claim is correct. It'll be an insurance policy in case I'm right. Now, this play it safe or insurance policy argument is getting very popular in many areas of environmental concern, from nuclear power to Alar on our apples. It upholds the strange ideal of an absolutely risk-free life, but it's not fair either. It's simply an attempt to snow people in the absence of convincing arguments, to stampede them by playing on their ignorance, self-doubts, or anxieties. There's no limit, after all, to the kind of insurance premiums that fearmongers can scare out of the emotionally susceptible. That's why the campaign against Alar on our apples focused on scaring mothers about the health of their children. Global warming proponents have the task of convincing us with facts and logic. Our minds should remain open to these, but not to fear-mongering from flimsy evidence. If a theorist can do no better, we have the right to remain skeptical or disbelieving. For now, the lack of hard evidence and reliable tools has left global warming proponents with little but a logical-sounding theory. It's possible that at some future date the logic will be confirmed empirically. But at present, the theory has seemed akin to an article of faith for some. Stephen Schneider admits that he bases his belief in the reality of global warming on what he calls, quote, intuitive reasoning, unquote. He says, quote, my faith is based on the principle of heat trapping by greenhouse gases and the billions of observations that support it, close quote. But like many others impelled by faiths, Schneider seems to have no compunction about forcing others to participate in his vision. And that brings us to the political and economic ramifications of the global warming extravaganza. Today, coal, oil, and other fossil fuels provide 90% of the world's energy. Yet some environmentalists, Schneider included, have proposed huge tax increases costing billions, even tens of billions, to discourage fossil fuels. Says he, quote, a few tens of billions or perhaps hundreds of billions of dollars spent annually around the world for such planetary insurance is an investment that is long overdue, close quote. Nor do the massive losses of jobs in existing fossil fuel industries seem to faze him. Quote, I realize that such a switch would be a staggering blow to the coal mining industry. But where is it written that anyone has an indefinite right to antisocial or anti-environmental employment? Close quote. In a recent draft report to Congress, the EPA suggested that, quote, the government could increase the price of fossil fuels by imposing charges or fees, at the same time reducing the price of desirable alternatives by providing subsidies, close quote. The World Watch Institute, a major environmental group, echoes this idea. It suggests a hefty carbon tax on fossil fuels to compel people to switch away from coal, oil, and natural gas and toward renewable energy resources, including solar and wind power and the like. Now, this proposal is among the most popular advanced in the environmental movement and was endorsed at a February 1989 international conference on global warming held in India. Schneider, who backs the idea of a carbon tax, conceded in his book that it will require us to, quote, redistribute our current resources, thus altering accustomed levels of expenses and incomes, close quote. Redistribution of wealth is explicitly advocated by Time magazine, which has jumped enthusiastically on the global warming bandwagon. Says Time, quote, Americans will have to find alternative sources for energy and use all fuels more efficiently. What all this requires is self-discipline on the part of the world's haves and increased assistance to the have-nots, close quote. Of course, such measures have a staggering price tag. Staggering, by the way, isn't my word for it. It's headlined in an article in the New York Times last November describing cost estimates made by an array of respected economists. The most optimistic estimate of the cost of first limiting and then cutting carbon emissions by 20% annually is $800 billion. The worst case estimate is $3.6 trillion cumulatively. Indeed, the most green thing about most of these environmental proposals is the color of the money it'll cost to pay for them. Senators Albert Gore, Timothy Worth, and others have introduced bills to force major expensive changes in fuel efficiency, to reduce carbon emissions, and to halt international deforestation. The idea of a gasoline tax has been floated as a trial balloon, hinted at by Senator Gore, but openly pushed by the World Watch Institute and the American Council for an Energy-Efficient Economy. Some proposals include major government spending programs to subsidize solar, windmill, and geothermal power, laws mandating fuel efficiency, swapping huge foreign debts in exchange for protecting forests, and increased efforts at worldwide population control. The political problem, of course, is how to build public sentiment for this taxing and spending orgy, particularly at a time of considerable red ink. Stephen Schneider admits to an ethical dilemma about all this. He concedes that there are many uncertainties about global warming. Nevertheless, to gain public support for his crusade, he explains that sometimes scientists, quote, have to offer up scary scenarios, make simplified dramatic statements, and make little mention of any doubts we might have, close quote. Each scientist, he cautions, must decide the right balance between, quote, being effective and being honest. I hope that means being both, close quote. For Schneider, Hansen, and company, one happy side benefit of being effective with scary scenarios and simplified dramatic statements is that it scares the hell out of congressmen into shifting millions of scarce federal dollars into global warming research projects run, coincidentally, by Schneider, Hansen, and company. The temptation to bend public fears for political ends is also ever present. Defending his environmental proposals, Senator Timothy Worth said, quote, we've got to try to ride the global warming issue. Even if the theory of global warming is wrong, we will be doing the right thing anyway in terms of economic policy and environmental policy, close quote. But the idea that bad science may be good politics troubles good scientists. MIT's Dr. Lindzen comments, quote, it seems to me that if science doesn't have integrity, it isn't of much use to people, close quote. We currently know far too little about a theory far too uncertain to be stampeded into rash, expensive, and coercive proposals. It's only prudent to continue researching and monitoring the possible effects of a continuing buildup of the greenhouse gases. But there are no grounds for sudden radical political and economic upheavals in the name of buying insurance. We buy finite amounts of insurance against demonstrable risks. We don't write blank checks against any conceivable anxiety. I don't relish the image of self-confident Americans becoming a nation of environmental hypochondriacs. If the greenhouse signal eventually emerges from the background data during the next few decades, we can then decide on the best course of action. But until then, based on my investigation, the best advice I can offer you about global warming is keep cool. Thank you very much.